Welcome back to today's session. In the previous sessions, we learned optimization of transportation problem by one of the methods called Modi method, right? But we remember that there was one more method of optimization, which was called stepping stone method. So after learning Modi method, today we'll be going into a stepping stone method. See, before I start off, let me tell you today's session will be a very brief, very small session where I'll be telling you what is stepping stone method, and I will just give you the procedure of stepping stone method. In tomorrow's session, we will be solving a problem on stepping stone method. Okay? So in stepping stone method, we evaluate the net cost change that can be obtained by introducing any of the unoccupied cell into the solution. So now what do you mean by this? See, you would have got an IBFS, which is a transportation table. You have made allocations. After making allocations, you have few of the cells which are unoccupied, right? For such unoccupied cells, if at all I include one such unoccupied cell as an occupied cell into the solution, what will be the change in the cost? That is called a net cost change. See, in Modi method, we compute the same thing, but we call it with a different name. We call it the net evaluations, your EIJ values, right? A similar concept is implemented here. We call it net cost change in this method. See, one important rule that we need to remember all the time whenever we are solving transportation problem is whenever we make a modification in the allocations, you cannot make a change or a modification in one single location. The only reason is if you modify and increase the allocation in one cell, then the supply constraint would get modified, which is not permissible. So if at all you increase in one place, an equal amount of decrease should be made in the same row so that the supply constraint will match. But column wise, there will be a change once again. Whenever you modified one cell, an equal amount of decrease should be made in the same row so that the supply constraint is matched. Similarly, an equivalent amount of decrease should happen in the same column as well. If not, the demand constraint will fail. Right? So that is what has been specified in this point here. The important rule is that every increase or a decrease in supply at one occupied cell must always be associated with a decrease or increase. When you increase, in the other place it has to decrease. If you are decreasing in the first case, it should increase in the second place, right? In supply at another. If at all I consider only row wise, then one increase should be supported by an equivalent value decrease in the same row. If at all I am decreasing in the first place, an equivalent amount increase should happen in the same row. The same rule holds good for the demand as well. That means to say in terms of columns. If one occupied cell is modified by increasing the value in the same column, there has to be another place where you are decreasing the same value. If at all you are decreasing in the first place, you need to increase it in the same column once again, right? This is a very important rule that we need to keep in mind. Thus, there must be two changes in every row or column that is changed. One change has to increase and the other has to decrease. This can be easily done by evaluating reallocations in a closed path sequence with only right angle turns permitted. What does this mean? When you get back to your Modi method, you remember that we were forming closed loops. It might be either quadrilateral or hexagon, right? What were we trying to do? In the same row, I identified 2 points. Whenever I consider a column, I identified 2 points in the same column. So, if at all the net evaluations have to be balanced, then it should happen in a closed loop, right? 2 rows and 2 columns, or 3 rows and 3 columns. Modifications have to be done. Only then you will be able to modify the solution without breaking the supply and demand constraint. Okay, so that is what has been specified in the last point here. So modification of the allocations can be easily done by identifying the closed path sequence, or identifying that rectangle or the hexagon that we used to do in Modi method. Same way here also we are supposed to identify a closed path, which will be either a rectangle or it will be hexagon. Okay, now we will go in detail into the steps or the procedure of stepping stone method. Step 1. Step 1 says determine an IBFS using one of the three methods. See, whatever has been specified in the problem, follow that method and find an IBFS. So as I said, first phase of the transportation problem has to be solved. Then only comes optimization. Straight away optimization is not permitted. So step 2, the number of occupied cells must be equal to m plus n minus 1. So that means to say it has to be a non-degeneracy case. What if it is a degeneracy case? Same procedure, whatever we did in Modi method, right? You just have to add an epsilon allocation in the least cost independent position, so that the problem becomes a non-degeneracy case. Okay, so now coming to step 3, evaluate the cost effectiveness of transportation in routes which are not currently in the solution. So that means to say, whatever allocations you have got in the IBFS, other than that, that means to say the unoccupied cells should be included in the solution and checked if at all there is an improvisation possible. Okay, that is what this sentence means. This testing of each unoccupied cell is conducted by following the 5 steps as specified below. So we have 5 steps using which we check whether an unoccupied cell can be included into the solution. If it is included, what is the net cost change it causes? Okay, so we will see this 5 sub steps. So the first sub step A, select an unoccupied cell. See, in an IBFS, wherever there was an unoccupied cell, select one such cell where transportation should be made. Right? I am selecting one unoccupied cell. Beginning at this cell, trace a closed path using the most direct route through at least three occupied cells used in the solution and then back to the original cell. So what does this mean? Starting from the cell that you have identified, draw a closed loop. Minimum, it has to be a quadrilateral, that is a rectangle. Minimum, it has to be a rectangle. If not rectangle, what next? It must be a hexagon, right? So, try to identify a closed path which is either a quadrilateral or a hexagon by moving in horizontal and vertical moves. Oblique moves are not allowed. As I said, only you can move in the same row or you can move in the same column. Moving diagonally is not permitted. Okay? The cells at the turning point. So in the closed loop, the vertices that you get, they are called the stepping stones on the path. We call it with a specific name called stepping stones in the path. Okay? Now we'll see the substep C. What does substep C say? Assign plus and minus signs alternatively on each corner cell of the closed path just traced, starting with plus sign at the unoccupied cell in the evaluated, that has to be evaluated. This is nothing different from assigning plus theta and minus theta in your Modi method. After generating the path, you are supposed to put plus and minus sign. Okay? After doing that, substep D, compare the net change in the cost. We are supposed to compute something called as net change in cost. How do we calculate this? Along the closed path by adding together the unit cost figures in each cell containing a plus sign and subtracting the unit cost in each cell containing the minus sign. Sir, what does it mean? Very simple. Wherever you had a plus, its corresponding Cij should be added. So I'll have 2 plus sign and 2 minus sign. Add Cij, 2 Cijs wherever you had plus and subtract the Cijs wherever you had minus. That will give you some resultant value, which will be either a plus value or a minus value or a zero value. Okay? It will be either positive or negative or a zero. So now repeat the substeps A to D until net change costs have been calculated for all unoccupied cells in the transportation table. Like you calculated Eij for all unoccupied cells, you are supposed to calculate net change cost for all unoccupied cells in stepping stone method. Right? You are supposed to find out that loop for all unoccupied cells. For all the loops, you are supposed to calculate the positive or the negative or the zero value that you get. Once you have done it for all the unoccupied cells, we will move on to step number 4. What does step number 4 tell us? Check the sign of the net changes. For all the net change values that you have calculated, look at the sign. If all net changes computed are greater than or equal to 0, if all your Eij values are greater than or equal to 0, an optimal solution has been reached. That means to say we have arrived at optimal solution. If not, if we have not arrived at an optimal answer, that is, if one of the net change values is still negative, then it is possible to improve the current solution and decrease the total transportation cost. So that indicates that still optimization can be done. If further optimization is possible, there will be a further reduction in the TTC. Fine? So if at all there is a further reduction in the TTC possible, how to do it? Go to step number 5. The step number 5 tells us select the unoccupied cells having the most negative net cost change, like you did for most negative EIJ. Here you will be picking the most negative net cost change and determine the maximum number of units that can be assigned to a cell marked with a minus sign on the closed path corresponding to this cell. Sir, somehow we did not understand this. It is nothing, it is very much similar to your Modi method only. What we are trying to do is we are trying to calculate the theta value here. Theta will be minimum of allocations at the minus theta locations. That is what we are doing here. Fine. Add this number to the unoccupied cell and to the other cells with plus sign and subtract this number from cells in the closed path with minus sign. So this is what we did in your Modi method also. The same thing we are following. So this will give me a new solution. A new transportation table will be obtained. So once the new transportation table is obtained, go to step 2, repeat the procedure until the optimal solution is obtained. So this is your procedure of stepping stone method. Now what I expect you people to do is, I said in the very beginning, today will be a very brief session. I'll just explain the procedure. I am not solving the problem today because before I solve the problem, I want you people to know the procedure correctly. So listen to this video maybe once or twice or thrice till the procedure is clear in your mind. Once the procedure is clear in your mind, tomorrow we will be applying that procedure and solving a problem. Is it okay? Fine. Thank you. Thank you for your patient listening. Kindly be home and be safe. Till then, have a nice time. Enjoy. Thank you.